So for section 3D, it's separated into two parts, D1 and D2, and so we're going to talk about D1 today, and we'll talk about D2 tomorrow. So just make sure when you look at your assignment that you do the D1 problems, okay? And so D1 is all about algebraic expansion. And the good news is that you are really, really familiar with algebraic expansion. I know you guys know how to do that. The thing is instead of using normal numbers and variables like we're used to, we're going to have some expressions that have variables as exponents. So you can jot down a stop box, because we'll come back to that. And then make sure you've got your heading on there for algebraic expansion. So the first slide we're going to look at is basically all the different types of expansions which you should be used to. So write these down if you think you need to. The first one here, if I've got a number multiplied by a sum, I can take that number and multiply it to both parts of that parentheses. What's this one called? You guys have done this a million times. Yep, that's just the distributive property shown in variables. The next one is just foiling, shown with variables. We know how to FOIL, and that's what I said. You've done this stuff a lot, but we'll just be doing them with numbers that we're not quite used to today. So we know when we FOIL, we have to multiply the first out or in or last. You might have to combine like terms, in this case with the variables. We don't. And then these three are really just foiling shortcuts. So you don't necessarily have to use these three because they are just shortcuts to foiling. If you don't like the shortcuts, you can just FOIL all of them. The first one is just the difference of squares. So if we've got two binomials that are almost exactly the same but have different signs, we know that middle term drops out. And then if I have a binomial squared, whether it's plus or minus, there is this shortcut that we can use. And I know I've used that shortcut in class. You guys have seen me use it. So again, those are optional, not required shortcuts, but you know how to distribute, you know how to FOIL. And so we're going to do two examples with distribution and two examples of foiling for today. Okay. So I'm going to show a whole lot of steps that I know that some of you are going to kind of catch on and skip eventually, okay? So just kind of keep that in mind, that I'm going to show a little bit extra steps to start out with until we get used to this process. So if I've got 7 to the x power times the quantity 7 to the x power plus 2. So I've got to multiply 7 to the x power to both of those things. So that means 7 to the x power times 7 to the x power, so like that first arrow, plus 2 times 7 to the x power. Is the red visible? None of the colors show up in the afternoon. It's really weird. It's like, I don't know. Okay. Now does it matter like the order that I write these two when I'm multiplying? Not really. So if you would have written it the other way, I want you to eventually change it so that the number with the exponent is like last. Like it's not wrong to do it the other way, but just kind of, you know how we usually put the coefficient in front? It kind of works like that. So then these are the same bases because they both have 7 for a base. So what do I do with the exponents when my bases are the same? You add them. So x plus x is 2x. And actually with this, I can't do anything else. 2 and 7 are not the same bases. I can't combine them. I can't multiply it because that 7 has that exponent. So I leave that exactly the same. I can't do anything else with it. We are going to do one more thing, and I'm going to kind of skip a step here and see if you guys are okay with it. That's like 7 squared, right? So we are going to actually square that, and 7 squared is 49, so our final answer is going to be 49 to the x power plus 2 times 7 to the x power. And I know you know how to distribute, but it's just kind of getting used to the way this stuff looks another one, but are there any questions or concerns? Okay. Now this other one has a little piece that might kind of trip you up for a second, but I want you to try it, at least try it on your own, just like we did. And then I'll clear it up. I just noticed a lot of people missing really small things when we tried it last hour. Okay, I see that it is tripping up most people, so I'm going to start going through this one together, okay? So just pay attention. So far, I know I didn't look at everybody's paper, but so far I only saw like one person that had it. But we'll do like the same thing. So I'm going to multiply 2 to the negative x to both of those. So that part's no big deal, right? And for this stuff, it's going to be okay to leave that as a negative exponent. I don't really want to work with a fraction right now, so I'm actually going to leave that kind of like we did on the last one. So 5 times 2 to the negative x. So if you do like change it to a fraction, I'm not going to mark it wrong. It's not wrong, but you don't need to take that step here. Does everyone hear me on that? We're okay? So now, same kind of thing. I've got the same bases. So I'm going to have 2, but I have to add x plus negative x. What's x plus negative x? It's 0. Well, what's anything to the 0 power? 1. So our final answer here will be 1 plus 5 times 2 to the negative x. So that little 0 power some people forgot about, which is okay. That's why we're kind of going through it. We're going to get to 2 foiling 1 next. Are there any questions? Okay. So here we've got 3 to the x power plus 3 times 3 to the x power minus 1. So again, I'm going to really take it slow on this first one to make sure you see all those steps. So 3 to the x times 3 to the x. So then I've got negative 1 times 3 to the x. 3 times 3 to the x, and 3 times negative 1, which again, I know some of these steps you guys are going to start doing in your head. That also kind of follows along with the way that it is presented on the very first slide we talked about. So now we can start simplifying and combining some like terms because I know that 3 times negative 1 is going to be a minus 3. If we look at these two terms in the middle, they both have 3 to the x. So what I can do then is I can actually combine like terms just like I would if it was like an x and an x. So 3 to the x doesn't change, but I can add it, like I can add or subtract the numbers out front just like I would with coefficients. So negative 1 plus 3 is 2. And then when I multiply these out, I have 3 to the 2x because remember we have to add up x plus x. Are we okay on all the steps? Yes.
I did.
I'm going to do one more thing.
I thought because you multiplied like 3 and 3 to the x power, that it made it like 3 to the 1 plus x power. That's
here or in here?
in the middle. That second. That one. I thought it made it 3 to the
Oh, you could do that. I see where you're going with that. You could do that, but it's not gonna like be as simplified as we could get. All right, so then we will just take that one last step and we'll write 3 squared as 9. So 9 to the x power plus 2 times 2 to the x power minus 3. That's a really good question too. I'm thinking about it more. We're just going to do one more. So are there any other questions? All right, so 2 to the x power plus 5 squared. Go ahead and try this one on your own. Remember that there are 2 options. You can use the shortcut or you can rewrite it. You can FOIL the whole way just like we did on the last one. Okay, how many of you guys use the shortcut? Just like show of hands if you use the shortcut. A couple? Okay, and then how many of you guys did like the whole thing? Alright, I'm going to do it that way first. So I would just kind of rewrite it to help me keep track. So then I'd have 2 to the x times 2 to the x. Then 5 times 2 to the x. Another 5 times 2 to the x. And I'm just going to do 5 times 5 is 25 on that one. Is that okay? So then, since I have these that are the same, I can add that up. So that'll be 10 times 2 to the x. And for this, we can write that as 2 and then 2 to the x. But remember, we want to write that as 4 to the x plus 10 times 2 to the x plus 25. So keeping that in mind, then we can write that as 4 to the x. Like I said, I know eventually you guys will start to get used to it, probably jump right down to writing it that way, but it's okay if it takes some time. Now, if you use this shortcut, we ought to square the first part, and I like to jump and square the last part. And then for a middle term, we have to multiply these both, and then we have to multiply them by 2 as well. So it's 2 times 2 to the x times 5. Well, the 2 times 5 multiplied to be 10. So I have 10 times 2 to the x. And once again, we can write that one as 4 to the x. So it does not matter which way you choose to do it. Any questions? You get the same answer either way. All right, so for your stat box, I just wanted you guys to connect this to language you're used to. So what are other phrases or words that mean product expansion? FOIL, so you can write down FOIL. What's that other one? where I just take it and multiply it to what's in the parentheses. Distribute. So just so when you turn to this page, you know, okay, that was just FOILing and distributing, even though it was a little bit different. And here is our homework. Again, make sure you are on the D1 section. Don't go to the D2 section.